Alright, here are our solutions for perfect problem 6 for Math 65. In this problem we're asked to factor this polynomial, but I kind of give you some specific instructions. So there's a couple different ways you can factor polynomials like this, trinomials when you have 3 terms. There's kind of this guess and check method that a lot of people work, but for this specific problem I want you to learn a different way, just so you have multiple ways of doing these. So another way you can factor trinomials when you have 3 terms like this is first rewriting it as a sum of 4 terms. Okay, what do I mean by that? Kind of like breaking these problems up into I think it's a 3-step process. So in step 1, what you want to do is find 2 numbers that, and it's always going to be, you want them to add to the coefficient on your middle term here. So we want them to add to 13. We want to multiply to the product of your first and third, to the product of the coefficient on your x squared term and the coefficient on your y squared term. So 6 times 6 is 36. So the 2 numbers that I'm looking for, actually I want them to multiply to 36. So multiply to 36, add to 13. You might be able to just figure that out. In case you can't, or if you want a method for figuring out when the numbers are worse, what we can do are come up with a list of factors of 36. Integer factors, because I don't want fractions or anything here. What I'm saying is come up with a list of numbers that multiply to give you 36. 1 times 36 would work. 2 times 18 would work. 3 times 12 would work. 4 times 9 would work. And I guess 6 times 6 would also work. And maybe I should put like a plus or minus over here because -1 and -36 will also work. So I have this big list, and then what I got to do is find one of these pairs so that they add to 13. Alright, if they're going to add to positive 13, first of all, they can't be negative. Right? Might as well just get rid of the plus or minus. Can't have them both be negative because when you add up 2 negative numbers, you get a negative number. We want a positive number, specifically positive 13. These all multiply to 36, but only these 2 add to 13. What I'm saying is the 2 numbers that we are looking for are 4 times 9. This is not the answer to our problem. This is just the answer to step 1 of our problem. In step 2, what we're going to do is replace 13xy with kind of what we just found, 4xy and 9xy. So what I'm saying is we're going to take our original equation, 6x squared plus 13xy plus 6y squared, and instead of writing 13xy, I'm going to write 4xy plus 9xy. So what I've done is I haven't factored this polynomial, but now instead of being a sum of 3 terms, it's a sum of 4 terms. And by choosing these 4 terms in the manner that I did above, I'm guaranteed that this thing will factor by grouping. That's exactly what step 3 is. It's factor by grouping. So when you're factoring by grouping, you, instead of looking at this as a sum of 4 terms, just take the first 2. Just take 6x squared plus 4xy. And look for a greatest common factor between these 2 terms. Well, if I focus on the coefficients, 2 is the greatest common factor between 6 and 4. And then I have x squared here and x here, so I have at least x to the first power in both of those. I don't have any y's over here, so my greatest common factor is just 2x. And if I pull a 2x out of 6x squared, I'd be left with 3x. And if I pull a 2x out of 4xy, I'd be left with 2y. What I've done is I've just taken the first group, the first 2 terms, and pulled out their greatest common factor, 2x. What I now want to do is take the next 2 terms, plus 9xy plus 6y squared, and pull out something from these 2 terms so that I'll be left with 3x plus 2y. This 3x plus 2y is kind of my target. I want to pull out something, so I'm left with 3x plus 2y. Well, let's see, to be left with 3x here, I'd have to pull out a 3y. If I pull out a 3y from the first term, I'm left with 3x. If I pull out that 3y from the next term, I'd be left with 2y, which sure enough is exactly what we need. So what I now have are two terms, one written in blue here and one written in green here. And each of those terms have a 3x plus 2y in them, meaning I can factor that thing out. Factor out 3x plus 2y. Try to write that a little more legibly. And then all I have left is this 2x and this 3y. What I've now managed to do is factor this kind of difficult polynomial using this method. At the start I mentioned that there are other ways to do this. The way that a lot of people learn how to do this is to just stare at this thing and say, okay, the numbers that I write here and here, the coefficients that go out in front, we'll have to multiply to 6 so that I get 6x squared. So you're like, all right, either it's 3 and 2 or it's 6 and 1 or maybe they're negative. And then the numbers that I write here and here also have to multiply to 6 so that they make this 6y squared. So again, either 3 and 2 or 2 and 3 or 1 and 6 or 6 and 1 or maybe they're negative. And kind of just start putting those down and sort of guessing and checking. The check method being when you multiply these all out, you have to make sure you get 13xy. And that works out fine if you can do a lot of this multiplication in your head, but I find in the pressure of a test that can be kind of problematic. So I like having a method that will always work, which is why I kind of forced you to do this problem this way, so that you have that method in your back pocket in case you ever want to use it. But I guess that's that, so I'll end the video here.